So today we are going to do lab number 4. Okay, this is the title of your lab: familiarization with Visual Designer for Arduino here, and implementation of a temperature sensing and control system using drag drop and. The objective of this experiment is to get familiarized with Proteus Visual Designer. Implementation of temperature sensing and control system using drag drop and play method. Harness the power of Proteus VSM and design our own hardware on the schematic. Often the trickiest part of embedded development is the hardware design. The Arduino ecosystem goes a long way to solving this problem with lots of ready-made sheets. Visual Designer takes this into the software domain using Proteus Professional Schematic Capture and Proteus VSM simulation engine to make simulation of complete Arduino system possible. The peripheral gallery in Visual Designer then simplifies the whole process, as it will auto place and auto connect the electronics on the schematic for you. Finally, Visual Designer provides high-level methods to enable the control of the embedded systems from a flowchart editor. Today, we will go beyond this drag, drop and play method. Proteus comes with lots of built-in peripheral, but today we are going to design our own peripheral, and the capability is limitless. Okay. Our main system that we are going to design today is the design a temperature sensing and control system. This system will have this visual warning. If temperature is greater than or equal to 40 degrees centigrade, then it will turn on red color light. If temperature is greater than or equal 30 and temperature less than 40, then turn on yellow light. If the temperature is less than 30, then turn on green light. So this is the visual warning to indicate the temperature level through different LED color, okay? So different coloring of the light. Now there is a cooling fan that will be controlled automatically by the system. If temperature is greater than or equal to 40, then run the cooling fan at full speed. If the temperature is greater than or equal to 30 and temperature less than or equal to 40, that means when the light is yellow, then run the cooling fan at half speed. And then when the light is green, that means if the temperature is less than 30, then turn off the cooling fan. And I have designed the entire system in drag and drop and play method, step-by-step procedure, and I have uploaded the video on YouTube channel. So on your left sheet, if you click the video link, you can watch the step-by-step procedure. That is drag, drop and play method. Okay, we drag, drop and play. We did not design any system by ourselves in that method. Now in this lab, what we are going to do, we are going to do our own fan control system. Look at over here. This is the part of the fan control system: resistor, a transistor, a diode to protect the motor. Okay, reverse current protection. This is a battery for the motor operation. Why we need battery for the motor operation? This is the completed circuit for the fan control. We need external battery for the motor operation. We cannot run the motor directly from the microcontroller. Look at over here. At pin number 3, IO3. At pin number 3, we connect the entire control circuit of the fan to the Arduino Uno microcontroller. IO3, pin number 3. What we do from the pin number 3, it is a PWM pin. We supply voltage output to enable this transistor. Okay, we don't connect the motor directly to the Arduino microcontroller board because motor draws a huge current. If that huge current flows inside the microcontroller board, that will get damaged. So we don't connect the motor directly to the microcontroller. Okay, what we do, we use a circuit like this is the motor controller circuit. We connect the motor through a transistor and a resistor to the microcontroller pin number 3 in the Arduino Uno board. And When we turn the transistor on by supplying a voltage, high voltage on pin number 3, look at over here, we connect the motor at the base, emitter, collector. On the collector side, we connect the motor. Then this acts as short circuit. This transistor acts as short circuit. In that case, the voltages get applied to the motor and the motor starts running. When we supply 0 voltage from our Arduino microcontroller board to this pin, this acts as open circuit. So no voltage is applied to the motor, motor is stopped. So we turn on and off the motor by using our microcontroller pin. And we give power or external voltage to the motor by using external power supply or battery like this. So this is the circuit, motor controller circuit, we are going to design by ourselves today. Okay, then we'll see how we can take the power of Proteus Visual Designer to program our system without writing any code by ourselves. Okay, so let's start the Proteus and let's do the entire system step by step. I'll show you part of the system design, then you can use the YouTube video to complete, because YouTube video is completely drag, drop and play. Okay, we have used the built-in peripheral in the YouTube video. So in that video you can find the rest of the things you need to do. Okay, so let me start Proteus and show you step by step how to build the fan control circuit. Right click the Proteus icon on your desktop, right click, then run as administrator. So we are going to create a new flowchart. Give a name. Lab for temperature control system. Okay. Okay, let's click the next button. Now this is the family Arduino. Our microcontroller board is the Arduino Uno, and this is the compiler Visual Designer for Arduino here. Looks everything is fine. So click the next button. Click the finish button now. So it will open up the window so that we can design our circuit. Yes, already it has the window. Schematic capture window, and this is the window where we can design our circuit. So this is the Visual Designer. So let's go to the tab schematic capture to design our circuit. So this is the already Arduino Uno board has been shown. Okay, let me zoom. This is the Arduino Uno breakout board. Okay, so look at the left. Look at the left sheet. Okay, first this is the connection to the microcontroller. We'll take the connection to take a wire or connection to the microcontroller pin. So we'll pick up this component. Okay, so let's do it. Right click on the empty space on the right side, place component, no, place terminal. Okay, go to the option terminal and click default. Okay, click default. So we have found a connection and we need to give a name or which pin we are going to connect. IO3. Okay, and we can lock it, locked. Okay, so we have the pin connection to our Arduino microcontroller board. It is already connected. Next thing, which is the next component, is the resistor. Okay, so we are going to pick up 1K resistor. So how to pick up 1K resistor? Select on the left side, look at over, this is the component mode. Selection mode on the left side, you see component mode, junction dot mode, okay, level. There are different types of operation that are activity you can perform on the left side. So pick up the component, so we'll select component mode. So when we select the component mode, then we can pick up the component. So click P for pick. So keyword, what we are looking for? We are looking for a resistor. So type resistor. So type resistor. Wow, lots of resistor, you see. Which one you are going to pick up? Just click the resistor. Okay. You can pick up a pot. No, we don't need to want to pot. Okay. We just want to pick up a basic resistor. Okay. There are different options. So let's pick up a basic resistor. Okay. Lots of resistor. Pick up 1K resistor. I think there are lots of 1K resistor available. 1K. Okay. Pick up 1K resistor from here. Okay, so we have picked up 1K resistor. Next thing, what we need to do, we need to pick up one transistor, TIP 120. Okay, this is the given name of the transistor, TIP 120. So again, click the P button and type TIP 120. Yes, we have found it. Fairchild NPN Darlington transistor. Okay, so click OK button on the bottom left right corner. Okay, so this is the transistor we have found for our motor control circuit. Next thing, what do you need? If you look at the left sheet, we need one motor, one diode, and battery, and one ground. So let's pick up a motor. So again, click the P button and type motor. Okay, lots of motors. Okay, so let's pick up motor active, simple DC motor model. So we can see the animation. Okay, active motor, we can show you the animation. So pick up the motor circuit. So this is a DC motor we have picked up. Now we just rotate the motor for its connection. Let's say horizontally, rotate 180 degree. Rotate. Okay. So we have got the motor. Then we need to pick up. Look at over here on the left sheet. The diode 1N4001. Okay. So again, go to the P button. Type 1N4001. Okay. So we have got 1N4001 diode. So lots of variation. Just pick up one over here. That will be nice. So this is the diode. What is next? If you go to the left sheet, we need a battery and the ground. It's a, I think 9-volt battery and ground. So pick up the battery. Battery. Okay. So how we connect the battery? Look at the polarity as is shown on your. Okay, this is the way we connect. But in any way you can connect. Just only it will that if you connect different way, it will give you different direction rotation. Right click, rotate clockwise. Okay, now let me do the connection. Okay, and place one ground. Right click anywhere, place, go to terminal and select ground. Place, go to terminal, right click, okay, on anywhere on the empty space, go to terminal and select ground. I think let's select this selection mode. Okay, then place, terminal, ground. Okay, now do the connection and connect actively to the lab sheet. Look at over here, this is the connected circuit. So connect actively to the lab sheet. Okay, click. Okay, take your mouse on the end of a device. Okay, like wire. Click, drag, and drop. Drag and drop. Connection is complete. Okay. Connection is complete. Again, take your mouse cursor at the end of the wire. Click, drag, and drop. Another click. Connection is done. So connect this terminal to the motor. Click over here, draw the wire, drag the mouse, drop it over here, and do another click. Done. Okay, connect this one to the ground. Done. Connect this portion. This diode is for reverse current protection. When you run the motor, it generates the back EMF, and when you stop it, then it produces a reverse current. Okay, so for reverse current protection, we use this diode. Okay, connect the battery. So our circuit, motor control circuit design is complete. Okay, so if you look at the lab sheet, I think our design is complete. Next thing, we need to add a sensor to sense the temperature. Okay, so let's add the sensor. So go to the visual designer, right click the peripheral, add peripheral. That sensor we are going to pick up directly from our built-in module. I think we are going to pick up one roof sensor. You see, thermistor based temperature sensor. Okay, so click add, click closed. Okay, the sensor, if you look at the sensor, it get connect to analog pin A0. Arduino Uno has 6 analog pin A0, A1, A2, A3, A4, A5 and A5, okay, A0 to A5, 6 analog pin. So we connect our sensor to analog pin A0. If you need, you can change it. Just double click over here and you can change the pin connection if you like. But for this project, this is fine with us. We connect to analog pin A0, the temperature sensor. Okay. Next thing, let me save it. You need to, I think, save your project frequently in case if there is any problem, you don't lose your work. Now go to the visual designer. Okay. This is the setup part. Our design is complete. Okay. Let me enlarge it a little bit. Our setup part, okay. In the setup part, we are going to define a variable of motor fan speed. Okay, let me create a variable fan speed because we need to run the fan at highest speed and mid-high speed. Okay, medium speed and not at 0 speed. Okay, so let's do the define a variable for the speed, new variable, and give a name. Let's call fan speed. Fan speed. Fan speed. Okay. In microcontroller, the speed can be varied in a range between 0 to 255. Okay. In a range in between, because output from the microcontroller is 8-bit. By using 8-bit, you can define 2 to 8, 256. That means 0 to 255. So any speed in between 0 to 255. 255 is the maximum speed. 0 is the 0 speed. So any variation in between 0 and 225 you can do. Okay, so you can fine tune the speed. Lots of speed variation can make in between 0 to 255. So it is an integer variable, and you can use the any value in between 0 to 255. Okay. So we assign initially the fan speed at 0 value. Okay, that's it. Initially, the fan speed is 0. So inside the loop, what we are going to do? We are going to sense the temperature. Read Celsius, for example. Okay, we are going to sense the temperature. Okay, so we are going to read the temperature is centigrade, and the value is getting stored in a variable called TMPC. This is built-in variable, but you can use your own variable if you like. Okay, so this is the variable that is holding the temperature at that point when we read the temperature. So next thing, we are going to test the value. Is it greater than 40, less than 40, less than 30, or greater than 30? Okay, so let's check a condition, pick up a condition block. So this is the condition block, decision block. The decision block, double click, we check. Temperature. This variable. Is it? Look at the left sheet. If you go to the left sheet, look at over here. Temperature greater than or equal to 40, then turn on the red color LED and run the cooling fan at full speed. So this portion I am going to show you in details, and this portion you need to do by yourself, but this is already done in the YouTube video. To complete this portion, you can refer to the YouTube video. Okay, this is very simple implement programming or simple flowchart. Okay, you can do it by yourself, the YouTube video, but I'll show you this part, fan section. This is the complex part. So let's set temperature greater than or equal to 40, run the cooling fan at full speed. So how to do it? We check temperature greater than or equal to 40. Okay, if it is true, swap yes no. That means this right side will be yes bottom side will be no. We can stop yes, no. So if temperature greater than or equal to 40, we need to run the fan at full speed. Okay. So let's define the speed of the fan by using the assignment block. Fan speed. Full speed is 255. Okay. So we have given 255. That's the full speed. Okay. Then we need to assign this full speed value to pin number 3 of the Arduino PWM pin. On the PWM pin, we can assign variable voltage output. On digital pin, we cannot do. Arduino has several PWM pin that we have seen in the last lab. Pin number 3 is the one of the PWM pin. It's called pulse width modulation pin. On the PWM pin, we can give variable voltage output. So we have given the maximum voltage at the PWM pin at this time to run the fan at highest speed. So it is a CPU method. Okay. So let's assign input output. That means we need to pick up input output block. I of operation. I of operation. Okay. Input output operation, because we are outputting the voltage from the microcontroller to the PWM pin number 3. So let's connect it and double click. So it is a CPU method. Object is CPU. From the CPU or microcontroller, we are going to analog write. We need to pick up the analog write. That means variable voltage you will output. So we'll pick up analog write. So which is the pin? Pin number 3. And what is the value? Highest value 255. Okay. So we are getting output the highest value at the pin number 3 to run the fan at full speed. Okay. So once you do it, your fan will run at full speed. Okay. Next thing, if the temperature is not greater than or equal to 40, what will happen? Temperature, according to your problem statement, if the temperature is less than 40 and greater than or equal to 30, we need to run the fan at half speed. So let's check that tested condition. So if the first condition is not true, that means if the temperature is not greater than or equal to 40, then it is no. Then we'll check the second condition. What is the second condition? Take the temperature variable and check it. Temperature greater than or equal to 30. Okay. Temperature greater than or equal to 30. Again, swap yes no. Swap yes no. Right click the decision block and swap yes no. So if the temperature is greater than or equal to 30, then you need to run the fan at half speed. So again, assignment, speed assignment block. Connect it and assign the speed. Fan speed. Half of 0 to 255 is 127. This is the half speed. So click OK. Now run the cooling fan at half speed. Again, pick up the I/O block, input output block. Connect it, double click the I/O block. CPU object CPU method is analog write, pin number 3, and speed is half, 127. Okay, so it will run the fan at half speed. Now if the second condition is false, that means temperature is not greater than or equal to 30, that means green light is on at that time, we need to stop the fan. Okay. So in that case, what we are going to do? Again, we need to assign the speed. This block, assignment block. Make sure that two dots are aligned. Double click the block. Fan speed is 0. because it is green light, green state situation. We need to test up the fan, and then put the output the value on the pin number 3 by the I/O block. Analog right, pin number 3, and the value I think for convenience, what you can do, you can give this value. Okay, it is a better way to program. You see variable fan speed. Instead of giving the value directly, you see we have already assigned the value to the variable. So instead of writing 255 directly, we can use this variable fan speed. Okay, because already we have given the new speed to the variable fan speed 255. Okay, so instead writing the value manually, pick the variable fan speed. Okay, it is a good way to program. Okay, this is a good programming practice. Okay, so this time, okay, if the temperature is less than 30, it will stop the fan. So let's combine the skid. That means when we run the fan at full speed, after this it will come to the point over here. When the fan run at half speed, again it would come at the end of the loop. Okay, so if you look at the diagram now, so little bit, I think one skin I am trying to bring it. Okay, so this is the entire program. Let's summarize. Let me save it. Okay, you need to save your project frequently in case if there is any problem happens with the software. Setup part, we have just define a variable of fan speed and initialize the variable with 0 value. The loop part, we read the temperature in centigrade from the sensor. Okay, and then we compare the temperature. If the temperature is greater than or equal to 40, we define the fan speed, highest speed 255, and we output this speed at pin number 3. So the fan will run at highest speed. But if the temperature is less than 40, then greater than or equal to 30, yes, then we run the fan at half speed. Okay. If the temperature is less than 30, then we stop the fan by outputting 0 value at the pin number 3. So this is the entire program for this fan control system. Okay, I did not implement the LED indicator or green light, red light and yellow light. That you will do by yourself, and if you need further help, you can check the YouTube video that is given in your lab sheet. Okay, that has been implemented. So let me simulate it. Let's see how it is working. Let me do the simulation. Click the simulate button on the bottom left corner. This is the run the simulation. When you click the simulation button, look at over here, Visual Designer. It is compiling your program. It is compiling your program. You can detach the window, the design window and Visual Designer, both window you can detach and can make it as independent window, or you can keep it together if you like. So it is compiling our program, compiled successfully, and it is simulating. Okay, so let's go to the designer window. Okay, let me little bit enlarge it so that you can visualize it little bit again. Okay. Okay, this green color on the left top corner, you see, as with my mouse I am this rectangle, okay, green color I am moving to set my viewpoint. Okay, once you are happy, click it, it will be fixed. Look at over here, temperature is 27 degrees centigrade right now, fan is stopped. So let's increase the temperature. Left plus button plus if you hover your mouse on the left top arrow of the sensor, and when it will show the plus button, if you click it, it will increase the temperature. It is now 28 degrees centigrade. It is similar the temperature increase 29 degrees centigrade. Again click 30 degrees centigrade. You see, 30 and above, the fan will run at half speed, and fan is moving at half speed. Okay. Now again increase the temperature. Take your mouse to the left top arrow, red color arrow on the sensor. When you see the plus sign, you can increase that. Click, the speed will get increased. 37, 30, 39, 40. Full speed fan operation. 40 and above, full speed fan operation. Fan is moving at full speed. You can decrease the temperature. You can simulate the decrease of temperature if you take your mouse on the down arrow on the right side, red color arrow on the sensor. When you see the mouse change to minus sign, click it, the temperature will decrease. Now 40 degrees centigrade, again click, 39 degrees centigrade, less than 40, half speed. Okay, so you can test it. Again, let me go below 30. Again, the click, reduce the temperature, 33, 32, 31, 30, below 30, 29, fan is stop, fan is not moving. Okay, above 30, fan is moving at half speed. So what is your job? You will follow this guideline to do your project today, and there is something more on your project. Let me stop the simulation. There is more on your project. Look at over here your lab sheet. You see, you need to give visual warning. That means you need to take 3 LED. Traffic light system already are familiar how to pick up the LED, red color, yellow and green. Similar like a traffic light system you have done. So you will pick up 3 LED, and on your visual designer you will write proper coding or proper flowchart for it. Okay, if you need further help, if you go to the website, I will upload this lab sheet on your discuss chat section. Okay, so if you click this video link, it has the complete drag drop play method design. Okay, a complete more sophisticated system, more bigger system, but it higher cost. Okay, we use a motor shield over here. Okay, we use a motor shield with more capability. That means in using motor shield, you can do more job for bigger system. Okay, but it will cost higher. Okay, so it has the complete design has been shown in this YouTube channel video. That is the design for this lab. Okay, so if you need further help to implement the traffic light code, to implement the visual light warning coding, okay, you can check this video. So let me upload the lab sheet to your chat box, chat section, and you can start your lab. Okay, once you do the lab, you just submit one screenshot of your simulation and one screenshot of your visual coding designer coding part, and then you can leave the lab. Okay, once you are done, when you submit, mention your group number. So let me upload the lab sheet on your chat section. Okay, Okay, now you can open the lab sheet and start your job. When you are done, just one submission per group, okay, one post per group, the simulation screenshot and visual design screenshot, okay, then you are done with the lab.